Phase integrated 3, it's problem 12-28. You've got a system of equations and it asks you to solve it, and it asks you what subproblems did you need in order to solve. So I always try to do these the same way every time. At first I thought we had 3 equations with 3 unknowns, but really we've got 3 equations with 2 unknowns, but I still go about it the same way. I'm going to grab equation 1 and equation 2, and I'm going to try to do elimination on them to eliminate one of the variables. I see it would be, I chose to eliminate y. Now I see maybe x would have been easy too, but I see if I double this bottom equation and then add it to the top equation, the y's will go away because I'll have an 2y plus negative 2y. So I'm doubling this bottom equation, and I didn't show my work. I'm just doing it in my mind. But I put a little 2 here to show that I'm doubling everything. Okay, so what I'm doing is I'm adding the first equation to the second equation, but the second equation is doubled. So 1x plus 2 times 2 makes 4x. 1x plus 4x, and then I just write the answer right here, that's 5x. And then 2y plus whatever 2 times negative y is, so 2y plus negative 2y, that cancels out. So that's why there's no y's here. And then 4 plus 2 times negative 7 is negative 14. So 4 plus negative 14 is negative 10. So then if I divide both sides by 5, then I have that x is negative 2. So I put that in the first part of my ordered triple. And then I don't know these two yet. So what I'm going to do is plug in my x. Plug it in one of these equations to find out what y is. So let's see which one I used. I went ahead and plugged it into the top equation. I plugged negative 2 in for x, and I got negative 2 plus 2y equals 4, and then I add 2 to both sides, and I've got y equals 3. And then then I had x and y, so I can just put it right here. X plus y plus z equals 4. So negative 2 plus 3 plus z equals negative 4. And so it turned out that z was negative 5. So basically we're using elimination and substitution to do these problems.